where each term is 4 plus 2n, and n comes from the set of integers. Okay. If you don't really get this part, don't worry. You won't see it again until a math class, or until you get to cisp300, which is discrete structure. How many people have seen something like this already? Oh, okay, good for you. It's a very useful thing, being able to kind of understand this type of notation. All right. So getting back to the part that can be in exam 1. All right. So going through this stuff here, I'm expecting everyone to be able to do the derivation and use also these steps. Okay. In other words, when I ask you what is the post condition of these lines, I don't want someone to give me just the answer. I want them to show me the derivation, why it is like that, and show me step by step how you derive that. And this is a template. You can just copy and paste this template, change the part that is specific to your homework assignment, and that will become a part of your answer. Do we have any questions about this stuff here? Yep.
I think I understand the how. So I think I understand the why do we do this exactly.
Why do we do this?
Yeah.
Because we want to verify the answer, or we want to verify the result of an algorithm, so that we can say, a definitive yes, and say that yes, this algorithm is correct. Okay? Instead of throwing test cases at it, we can just blanket and say, yep, I know it has to be right. Given what you tell me about the restrictions of the input, this is guaranteed to be the output. I don't have to throw dots anymore.
So it's like mathematical proof instead of experimental proof.
Exactly. It is a mathematical proof of the correctness of an algorithm. So you don't have to throw little darts and use test cases to give yourself that kind of warm and fuzzy feeling, but never really sure. Yep.
We're trying to get to general statements for each line, pre or post.
Right. But that's because the entire program is a sequence of
It is an algorithm.
statements. So if you can go from one statement to the next, eventually you can go from the precondition of the entire algorithm to the post condition of the entire algorithm. Now, assuming that you did not make any mistakes in the derivation, you can compare the post condition of the algorithm to the intended result of the algorithm. If they are exactly the same, or if one can imply the other one, okay, let me see which one has to imply which one. If the result of the algorithm implies the description of the correct result, then you're good, because you're guaranteed that the algorithm is correct. Does that answer your question?
Yeah.
The intent of something like this, the unintended result of this, this is actually after I started to type this entire section about pre and post condition, is a lot of times it's the reverse application that is useful. Given the post condition, you have to derive the precondition, because this is how you can walk your way back from a program that has crashed. Now, a lot of times when a program crashes, especially in Linux, I think in Windows it has that option too, it will create a core dump. Okay, how many people know what is a core dump from a program? Okay, a core dump is basically a program capturing everything in RAM during the execution. So if you have the symbol table and all the other good stuff to go along with it, you can actually know that, oh, okay, the program crashed exactly on this line, and at that time, these variables have all these values. In other words, you can take a snapshot when the program crashes. So the question now is, okay, this is where it crashes, but what is the reason why it is crashing over there? The reason is usually not on the line where it's crashing. It can be 5 lines back, 20 lines back, 300 lines back. Who knows how far back you can go? So that's why we want to be able to analyze a program backwards, so that we can try to figure out, okay, how do we get here? Yep.
So you're saying we could learn how to troubleshoot kernel panics?
Kernel panics are a little bit Yes, the approach is the same, but kernel panics can be a lot more devious because it's not deterministic. Because things can be happening quote unquote in the background. So and you can never really model all those things that can happen in the background because it's not deterministic.
It's modular, right? So that's
Right. You can try to debug things in a modular fashion, but once you throw them all together and then you have timing issues and things that are non-deterministic, debugging can get a lot more difficult. And the kernel falls into that category. Yep.
Isn't it, I don't know, I want to say more efficient or better to debug from top down, from line 1 to error?
After the crash.
That's a good question. How should you debug a program? Now, a lot of that has to do with experience too. Okay, so I'm gonna get back to that question, and I'll let you. Yep, go ahead.
Would it depend on how, like, you're debugging a program? I mean, if it never ran the program and you're checking it for bugs prior to running it, then top down would be more efficient. But if the program is crashed, then going backwards from the crash to the beginning is more efficient. Because if you're
Yes, because if you already knew why it crashed, you would have put it into the test cases already to catch it early enough, right? So let me just use an analogy instead of doing this programming, because we troubleshoot all kinds of things day in and day out. So I'll use this actual case of troubleshooting and kind of use it to illustrate what it means when we're doing this. A long time ago, I had a Ford Escort, okay, 94 Ford Escort, one of the best cars I have ever owned. Inexpensive, cost effective, fuel efficient, and nobody bothers to steal the car either, because it's worth nothing. Great car. So anyway, one day it started to kind of have hesitation when I tried to accelerate, and the idling is rough too. So I took the car to a shop and kind of drop it off and asked the guy to find out what's wrong with the car and fix it, right? 2 days later, the car, I went to the shop and asked, okay, so, what's happening with the car? Could you fix the car? Did you find out what's wrong with the car? The guy said, no, I tore my hair out and I still could not figure out what's wrong with the car. He did not charge me a penny and just said, well, you probably should take it back and take it to another shop. I kind of felt sorry for the guy because, he actually tried his best and did not get anything out of it and could not find out what's wrong with the car. So how would you approach that problem? It's troubleshooting. So for people who kind of have some understanding of car engine and stuff like that, what would be the first thing you look? Timing. Okay, you can check timing.
You have to look at the physical components, make sure all the connections are there and there's no disruption.
Okay.
So you can look at the coding. There's probably a computer that's misfiring one of the cylinders or something.
Okay. Yep. 94 Ford Escort. Okay. The problem was, one of the spark plug cable has a puncture. Okay, and it was grounding on the engine block itself, so the cylinder was not getting the ignition, and that's why it was running rough. Okay, and it was a difficult problem. Okay, it was a difficult problem because the spark plug cable cannot be visually inspected for that sort of a problem, because even though there's a small puncture, you can actually see it if you know ahead of time that it's grounding. But if the cable itself is dark in color, there's nothing you can see. Until you turn off the light and try the engine, and you can see the spark going from the spark plug cable to the engine block. Okay, but getting back to this, the context of troubleshooting. So what you need to do is to figure out, okay, what can cause the problem, right? Okay, what does combustion need? What does a smooth running engine require? Correct timing, spark, fuel delivery, the correct air fuel mixture, and so on and so forth. So you have to start with all those things, and if the car is not running correctly, now this is getting back to the square root or the mod, the remainder example, because there's not a single thing that can cause an engine to run rough. Okay, it can be many of those things. I mean, you guys gave me all the good ideas. It can be the timing, the distributor, it can be the spark plug itself gone. Okay, maybe the spark plug itself is corroded enough that it is not sparking anymore. So you kind of have to go back step by step and check each one and say, okay, we checked that one, that is not the problem. Moving on to the next possibility. It's the same thing with programming. Okay, so why are some people more efficient with debugging a program only takes them like 1 day to find a really tough problem, and some other people will spend 2 weeks and still not be able to find a problem, assuming they're all honest and really hardworking, right? Yep.
Because they're probably looking at their own program, and if they're looking at it top down, they're making assumptions that everything being inputted is correct.
That would be one, because if they wrote that bug to begin with, it is unlikely that they will check for that thing when they try to debug a program. Yep.
Experience?
Experience, that's it. Okay, experience is the other thing. Like in the case of the car engine problem, someone who is not experienced, can have all the knowledge of how an internal combustion engine works. Okay, but follow the wrong branch to begin with. So we'll think, okay, maybe it's the timing that is wrong. Okay, so if the timing can be wrong, I have to check the engine control computer, and then if the engine, so it will just go on the wrong side or wrong branch, and then you can go very far upstream, to confirm that, oh, okay, I guess that was a dead end. It was not because of this problem. Okay. Now, people with experience, having encountered many cases of a rough engine running, know that the probabilities, right? Okay, chances are, okay, these things are more likely, so I'll check those things first. Or this thing is really kind of not likely, but it's very easy to check. Okay, it would take me 5 seconds to check it, so I'll check that first. Okay, I know it's the probability is very low, maybe 0.2%, but since it only takes me 5 seconds, I'll just check it out, and if that's not a problem, I don't have to worry about that anymore. So a lot of that has to do with experience. Now, getting back to some of those students at UC Davis that I mentioned in a previous class, they were doing some random stuff. So in this case, it would be equivalent to taking all the spark plug cables and switching the order. Would that have fixed the problem? Would that have made it worse? Yep. You wouldn't have it running, but it probably won't hurt the engine.
Depends on when the thing fires, if you can burn the engine on.
Because you can have the thing firing
Yeah,
when it's
1,
not
2
supposed
firing,
to.
It's supposed to be 1, 5, 3, 7, and so on. Fire at the wrong time. Proper firing order.
But if it's not in a proper firing order, would it not have a fuel air mixture at the time to burn anyway?
It depends on the type of engine.
Yes, it will.
It will?
Yes.
So it will blow up, or it won't have?
It'll be like really rough. If you fire in order, you get one wrong, it'll start to shake.
Of course, now it gets even worse than that, because if the computer of the car, the ECU, detects there's a problem, it will try to fix itself, right? It would try to change the timing and change the fuel air mixture and stuff like that. That can actually make it worse, because the car, the intelligence of the ECU is based on assumptions, right? It's still assuming the cables are plugged in correctly. So if you change the ordering of the cable, it's like, okay, there's nothing that can save it now. Yep.
I think that's difficult trying to troubleshoot a rough engine. What about the F-35, the aircraft that uses fly-by-wire? I wonder what that would be like to troubleshoot the algorithms for that one.
Well, that's a good question. Now, I think we are digressing, but I think it is related to computer science and software development in general, because these days if your car is broken, okay, or it's idling rough, something is wrong, you get into a shop. The first thing the mechanic will do is to look at the computer. It will ask the computer, tell me everything